Thanks. Hey everyone. This is my first Elm conference, and I'm a little bit excited and nervous, but I think it's going to be fun 2 days. So I'm going to talk a bit about how I learned Elm and how we switched to it for a project that I'm going to talk about, and how I learned Elm, basically the major parts of it within 3 days, and I'll show you a little bit of the code that I had at the end of it. And I think that also speaks a bit to the language, but I'll get into that later. So a little bit about me. I normally don't do much front-end programming. As a day-to-day job, I'm a consultant. I do back-end engineering, and at the moment I'm doing a lot of site reliability engineering that includes things like load testing, Kubernetes, container deployments, and automating all that. So very back-end heavy. But I co-founded Syncrypt, which is an early company, startup, whatever you want to call it, project, with 2 friends in late 2015, and we've been working on it all as a side project. So we're still doing full-time jobs on the side, but we want to bootstrap this as much as possible, so that's why we've been doing that. And we've grown to 5 people over the course of the last couple of years now. I live in Germany, Osnabrück. That's a town. If you've ever been there, if you ever go there, say hi to me. Let me know, and we can meet up. All right, so I like to learn programming languages. I'm a big programming language enthusiast. I've learned a lot of programming languages over the last couple of years. I even created my own many years ago, and I realized it's actually in there, which is kind of funny. So this graph shows like the interconnectedness of a lot of the languages, how they influence each other, and it's kind of interesting to see you have these big clusters, but in the end it's just like this big web of mess in a sense, because everything is boring from everything, I guess. And this talk's going to be about how I discovered Elm and how it surprised me in ways I wouldn't have thought or I wouldn't have expected initially. Most of you probably have made the same kind of similar transition over the years. So I used to do a lot of small talk style object orientation, dynamic dispatch, all that stuff that you probably know about. Dynamic dispatch is pretty powerful, but it also can make your code really hard to understand. And I think that's especially the case if you pair that with mutable state. And functional declarative programming really solves a lot of object-oriented OOS problems, let's say it that way. It's hard to say. It does introduce some other ones, so there's definitely complexities with functional programming, but I think it solves a lot of the really fundamental problems of mutable state and object-oriented programming, or imperative programming, if you want to call it that. And overall, my coding style has shifted more towards the functional style of doing things. So a little bit about Syncrypt. I don't want to talk too much about this, and I recommend checking it out later. The slides, I will tweet them, I'll upload them after the talk, and you can check those out then, and I guess there will be recordings as well if you want to read through that in more depth. But basically the TLDR is that we are building a file sharing and file sharing and backup service similar to like Dropbox, where you have folders and you can just put files in it, and then if you invite other people, they automatically get the latest version of the file, and all the encryption is all done client side, so you basically don't have to trust us. And we use some advanced techniques. We started introducing a transaction log for each vault. So vault is just like a folder that you're synchronizing with yourself or with other people. And we have this transaction log, which uses cryptography to verify and make sure that no third party can tamper with the history and the changes made to a vault. So that prevents things like tampering with the authenticity of uploaded files in their metadata. There's no way really to put in files in there that weren't cryptographically validated to be there. It's also fully open source. The front end, the client stuff is all open source, and our basic goal is to create a simple to use file storage and synchronization service that you don't have to trust. So a little bit of history about the project itself. We started working on it, as I mentioned, a couple years ago. I was mostly working on the server side at the time, working on a Elixir backend that we still use, and that does all the file storage stuff. And since I wasn't really doing a lot of JavaScript at the time, you could say I wasn't really used to the JavaScript ecosystem insanity, is what I like to call it. Here's a little video where you can see our command line interface that we had in the beginning. So we didn't start out with the graphical user interface. It was just a CLI and then a background daemon that uses the same kind of code. And you can see I uploaded some files, and then I'm downloading them, looking at some Vault information, and then looking at the log. Here you can see our initial JavaScript and React-based prototype, and don't mind the design, we've changed it completely, but you can see like some basic interactions there. And I struggle with JavaScript quite a lot, so I don't really do a lot of JavaScript normally. And coming into this, and my friend who was working on the encryption part, he didn't have a lot of time working on that as well, so I focused a lot on that. And it was quite hard. So as I struggled with that, I looked into Elm, and that's when I oh, there we go. Okay, sorry. So this is the current. Yeah. Anyway, this is the current version implemented in Elm, and you can see there's some more stuff, more features that we have at this point. There's a file browser. You can untick each of the files, and that's all done using ports. So since this is running an Electron, which is obviously using Node.js, we can also talk to the file system, and we're using ports to get that kind of information. And you can see we have these modals, and then you still have the background information. Here you can see some things that the daemon is doing in the background, so it's easy to see what that is doing. And then we have a settings dialog as well, and you can see we're switching languages, and it automatically updates all the UI to the new language. So currently we support German and English, and I will talk a bit about how we implemented that as well. But first I want to talk a bit about React and Redux and why we initially chose that. So I really think that the model that React and Redux combine really, that it makes a lot of sense, and I think it's a great way to write applications. But it has some downsides. I think there's a huge complexity in the implementation, and actually also when trying to use it with different libraries, and the syntactic overhead I think is a little bit weird too, but that might be, that's a matter of taste, I guess. It felt hard, though, to get into a productive state. So the language and the library ecosystem felt pretty brittle. There weren't any type guarantees, obviously, because it's JavaScript. And it's pretty bad or hard to configure the tooling. I don't know how many hours I've wasted on grunts and like packaging stuff and like getting Electron to work. It was disheartening in the beginning, to say the least. But pair that with bad runtime errors, useless stack trace in a lot of cases, and hard to find good documentation for making it all work in one easy way. Like that was really hard. And since I didn't want, it felt like running against barriers the whole time. And then I discovered Elm. And so, I found out about Elm by reading about React and Redux. I had heard actually about it a couple years before, because I always read up on programming languages, but I never had the time and the motivation to look into it, because I wasn't really a front-end developer. But this project obviously changed that, and so what I discovered was there's pretty good documentation for beginners. There's really great tooling and editor integration. So I started out with using Atom, switched to Visual Studio Code since, for different reasons, but that works great in both editors. There's great tooling there. And for other editors, I'm sure as well. There's great compile time error messages, and I never really read a book, because why do you need a book if you can just let the compiler tell you how to write your program? Kind of. So I was going to talk about the compiler errors, but I'm pretty sure most people have seen those already, and probably learned a bit more about the language by just reading and understanding those and working through those. So I'm just gonna skip that part. Let's just acknowledge the fact that Elm's error messages are awesome, and every other language creator out there is probably envious and trying to incorporate them into their own language in some way. I was also going to talk about the strengths of Elm over JavaScript and React and Redux, but that's probably more to the fact that I really like some things about how Elm does it, and dislike the other things, and that's maybe more about taste. So for example, the JSX syntax, some people really like it, and I think it fits in with if you're really in this HTML world a lot and you really like HTML syntax, which I don't understand how you would like that, but anyway, that's a matter of taste again. So I prefer just using functions like Elm does it, and I think about it this way, like if you want to generate data dynamically, in this case HTML markup, and you want to fill in parameters as needed, well, that sounds you need a function, right? I mean, you're just creating data and you want to pass in arguments that make sense to use a function there. So I really like that approach. It just, the whole language seems very cohesive, and you're reusing the same kind of tools for different parts and it just makes sense, I think. But again, this is maybe a little bit personal and subjective, so people might have different opinions about that. One thing I really do like about Elm, though, is its very simple core model of how you write your applications. There's just pure functions, there's values, aka immutable data. There's managed effects, which is great, so you don't have to deal with all the intricacies of that. And I think this is one of the biggest things that people maybe, I don't know if people talk a lot about this, but that I really like about Elm is the fact that it just has total functions everywhere, so you have to handle all the cases of every variant of arguments and functions. That the compiler checks all of that, and it just makes it really easy to try things out, because you're always guaranteed to have a working program that usually works the way you want it to by the time you can actually run it. And then you add the simple and concise syntax in most cases, and its semantics obviously are super simple as well. So there's really a lot of good things about Elm in its simplicity that really makes it easy to learn, but I think also to maintain code bases over time. And I want to go a little bit into some code that just demonstrates some of the nice, simple features that I like about Elm a lot. So as I mentioned earlier, we have the translation part where we have different languages that we support, and I just wanted to go a little bit into that. So this is our main model, and it might seem scary, but that's why I blurred out most of it. It has different states for the different modals that you saw. You can actually click on different vaults and do stuff in there and then go back to another one, and if you go back to the original vaults dialog, it'll still have all the states, so we keep that all there. And but what I want to focus on is the language part there, so that what is not blurred out. This language thing, the type is defined up there. So right now it's just a unit type with 2 variants, and we'll just add more as we need more languages. And then we have these extensible records, which you probably know about as well, but they let you just focus on a subset of fields that you're interested in without having to worry about the whole model in that case. And so I really like that part too. And we use the same kind of thing for the settings dialog thing, and you can ignore the most of the specifics, but we have some stuff in there that it triggers and changes in the model. Using extensible records has a couple of benefits, I think. Probably most of you are familiar with, but it just allows you to focus on that part, similar to what I just did on the slide visually over there, right, in a sense, but at the type system. So how do we implement this switching part? I mean, probably guess it's pretty simple. We have a button called language button. It takes a language that you want it to switch to when you click it, and then this has settings dialog thing, which is the model that gets passed in, and then we just create a message at the top. When you click that, I mean, this is a helper function. The button down there, we have some of those, so don't worry if you haven't seen this kind of explicit calls before. But either way, it's just triggering this language selection message, and so that's what we handle then in our update code. We just set the language to the one that was clicked by the button, and then we also call this daemon.update GUI config, which actually persists that setting in a file locally, and it does that by talking to the daemon. So it just makes an HTTP API request to the daemon in the background, which then manages all the configuration state and everything that's related to that, and so the UI doesn't really have to worry about it. But obviously, we want to make sure that next time when you start the app, it's going to use the language that you selected last time. So that's why we do that here. And then to actually do the translation is pretty simple. So we have this translate function down here. It takes a language, it takes a text, and this text thing I'll talk in a bit about, but it's basically anything that can be translated. And then it returns a string, which we then put into the HTML to display it. And then, yeah, I mean, the code is pretty simple. We have some extra functions for each language, and then the thing at the top is just a helper, because it really is nicer sometimes in your view code to just write T instead of translate everywhere. Just takes up less space, I guess. It's a little bit easier to read. I think this is kind of interesting. So first of all, by doing it this way, by not using some external system, which I really didn't want to bother with, just for the 2 languages right now, I didn't want to incorporate another system for doing the translations and that kind of stuff. The interesting thing is here now we can't have any missing translations, because it's going to give you a compile time error, and you can't have any you don't have to deal with the weird external templating translation system that are out there. I've never had to do that before, and I really didn't want to look into it yet, so this was an easy way to get it going. I think for smaller number of languages, this is probably a really easy and safe way to support them, and also to maintain them over time. And then here's just a little bit more from that. So we have here's the beginning of the implementation for the Translate English, and it's using this text thing, as I mentioned, and you can see here's the different subtypes of that text. So we have different text for like notifications, we have some for different reasons why something failed. We have some statistics that we show in the bottom, which you might not have seen, but don't worry about it. There's a place where we show some stats on traffic, uploading, downloading, and that kind of stuff. So that's where we can show that, and then on the left you can see how we just, for English, we just return the right translation. But obviously it didn't start out like that. In the beginning we just had English, and this, as you saw in the video, this is what the old UI looked like, and I want to show you what I had after 3 days of learning Elm, never having touched it before. So this was the original, talking to the daemon, showing the vaults on the right. That's just some informational thing that we got rid of, actually. So this is after 3 days, and it's not fake data. It's actually talking to the daemon. And I was surprised by how well this went. So when I was starting into it, I obviously ran into a lot of errors, but as I got these errors from the compiler, I actually learned more about the language, and that allowed me to become faster and faster and faster. So after 3 days, I had a basic prototype working. Most of the UI wasn't there yet, just this view, but I really like that. Like, even with all the styling, I just moved that all over. As you saw earlier, we called into this daemon module, and that basically is another module that we have with a bunch of helper functions that generate API requests for us, and I just wanted to go over those really quick. So we have this API path type that lists all the different API paths that we support when you do make requests to the daemon, and by wrapping it in a type like this and then having a function to actually translate to the real path, we can guarantee that we can't accidentally use the wrong path when hitting the API. So again, trying to incorporate and use more of Elm's features to actually make it easier to maintain this over the long term. And as you can see, here's 2 example implementations of those. So we have, for example, the get stats. We call that every couple of, there's some interval, and you can configure that as well, but by default it's within every so-and-so many seconds. We hit that, and we update the UI based on that. And then we have another one called get vaults, and as you can see, they both use, first of all, this get, which means it's a get request, and I don't know, this is, I'm not sure if this is the best way to do it, but anyway, that's what we did. We also define like the get, post, put, delete, and then we have this would be a path. So in that case, we want to get the vaults, and then this would no empty body, obviously, and then the decoder here, and then we pipe that into a message, turn that into a specific message, because we always want to use that actually. And then finally, here's the API request method, or not method, function. Yeah, still got to get used to the naming there. But I think it's pretty clear what it does. Like, you have to read through it. We don't have to go through all of it. But overall, I think Elm's syntax and coding style really, it's pretty readable. This almost looks like pseudocode in some cases. And then we have the headers down there, and we're using a special auth token that we send along with the headers to prevent to prevent basically some kind of attacks that you can run into that I won't go about. The main thing I actually want to note, and I think people know this probably, but the remote data module is really great. It forces you to handle different cases, or all the cases of something that you get over the network, what state it can be in, so loading, failed, or successful responses and that kind of stuff. So we use that a lot for all our API requests, and that means we always are forced to actually deal with things like when it's loading, and so that's really cool. Always good loading animations and never having stale data there. And so this is after 3 days. This is what I had. This is literally, I checked out the revision from after 3 days, the last commit I did that day, and then checked out the tree and copied the code from the decoders in. And as you can see, I soon switched to the JSON decode pipeline package, because it just, I think, makes it a lot easier to read. And Yeah, I don't know, this felt pretty simple. It looks pretty simple. It converts it into the types that we want. One thing I noticed, though, is by using decoders, I was forced in a lot of times to actually, we were forced in some cases to change the data that we're sending from the daemon to the client because it just made writing the coders pretty difficult. And that usually hints at that the data model, it maybe isn't the most easiest you can make it. So I like decoders that are easy and obvious to read, and that kind of means that I like data structures for which it is easy to implement decoders. And I don't know, you might not be able to always do that, but if you can, I think it makes sense to just restructure your data, and then everything becomes usually a lot easier. Elm can be fast. What I mean by that is it's great for discovering code or your own code and using the tooling to get great feedback when you're changing stuff over time. I think the language is really readable as well. And so it's really easy to get back into a productive mode. As I mentioned before, we only work on this part-time, so I don't have time every week to work on it, or only maybe a couple days a week. And I don't know about you guys, but if I haven't worked on something in a longer time and I get back into it, it can take a while. And with JavaScript, I felt like that would take so long just to understand again, get into the mental model. Whereas with Elm, it's just like pretty much instant. The way I start features is I just change the model, then get the errors from the compiler, and then I know, oh yeah, I forgot about that. Oh yeah, there and there. So that's great. It can also be slow in the sense, that's what I mentioned with you get all these errors. You can sometimes feel like Elm can feel like it's a little bit verbose, or like the compiler is getting in your way a lot, but every time I get frustrated at the compiler, just a short moment later, it tells me about a place I have to fix, and I'm like, oh my god, I would have totally forgotten about this in every other language, so thanks. Like, you just, prevented a regression that would be really hard to probably debug in most other languages. So that's actually the core strength, like forcing you to be deliberate about your things and actually making the right choices when you can, and enforcing that is great. So, do these approaches make sense? Is this idiomatic Elm? I don't know. It's still my first program, but I felt like I felt productive from the beginning, and I do know that Elm made it really easy for a newbie like myself to the language to get productive within the first couple of days, and it has been a blast to work in. I always look forward to working in it again. It's just, I don't know, it's just a fun little thing. So that's it. And if you have any questions, if you have anything you want to look up, those are the links. One thing I really like too that I did look into after those 3 days is the elmtutorial.org. I think that's a really good introduction to like more of the specific, more complex things if you're interested in that as well. And yeah, if you have any other questions, let me know. I'm happy to talk during the whole conference, and happy to see more talks over the next 2 days. Thanks.
Thank you very much.